Okay, going to do a quick screencast here to explain the relationship between wavelength, frequency, velocity, and how the medium affects those things. It might be obvious, it might not be obvious, so let's talk about that. I've got an example here where I've got an incoming light ray coming in, incident to a boundary between air and glass. It's going to refract when it enters the glass, so it's going to bend towards the normal because we know that the index of refraction for glass is greater than that for air. So remember how the index of refraction works. It's equal to the speed of light in a vacuum versus the speed of light in the new medium. So it's a ratio of those two things. It's always, other way around, greater than or equal to the number 1. Okay, so we know that glass has a higher index of refraction, so a slower speed of light in that medium. So remember the equation for waves in general. So the velocity of the light is actually changing when I go into the glass. The question is, what's changing over here on the right side to make that velocity change? Is it the frequency or is it the wavelength? Remember the frequency. You might remember this from AP Physics 1. The frequency is determined by the source. So the source isn't changing. Whatever's creating the light up here, if it's the sun, if it's a laser beam, if it's an incandescent light, whatever the light source is, that the source of the light is not changing just because it changes mediums from air into glass. So it's definitely not the frequency. It turns out the wavelength is going to change. So frequency stays constant when light passes from one medium into another, but the wavelength adjusts. So if you think about the ratio, the index of refraction actually being a ratio between the speeds, the speed of light in a vacuum, I put C with a little v for vacuum. I really don't need to do that because C is automatically the speed of light in a vacuum, versus the velocity of light in the glass. That's what that ratio is. So knowing that that's equal to f lambda, the speed of light in that medium, I put the frequency of the light times the wavelength of light in a vacuum divided by the frequency of light times the wavelength of light in the glass. I can cancel out the frequency because that's a common factor. So you can think of the index of refraction as not only being a ratio of the speeds of light in the medium, but also a ratio of the wavelengths of light in that medium as well. So hopefully that helps remind you what changes when you go from one medium to another. It's the frequency staying constant, and it's the wavelength that changes. And I will see you at office hours if you have any questions. Stay safe and stay close to home. Take care.